Thank you to the Honorable Minister for having me here. I think it's testimony of the support the government gives today to startups in India. And 10 years ago, I wouldn't have anticipated that I would be here at an event, sitting with such an august gathering. I think if in 5 years from now, I mean, some of the younger guys here should take pride, and also the fact that if a clown like me can come here, you can do better than me. Yeah. And the choice of Future Labs is very interesting because when we found Sankhya, we named it as Sankhya Labs, so that most of innovation happens through tinkering, right? And at that time, a lot of people used to come to our office in Hendu Road in Bangalore and ask us whether we do blood tests. So they thought that we are a pathology lab that actually does stuff. So I think as an ecosystem we have matured where we really now know that we can name companies and ecosystems as labs, and that shows the sign of maturity. My talk is a bit more specific and a bit more technical, and I'll take on Keith's challenge of monopolies, and I'll talk about a few monopolies and how monopolies are a detriment to creative destruction. I think as a part of the startup process and also as a part of the growth, creative destruction is a very important aspect. And then to allow new entrants to come in and build stuff is very important. So one of the parallels that I would give and is the model that India has adopted for UPI, right? And that has actually practically changed the world of fintech and broken down the monopolies of a few credit card companies. And I'll talk about also in an electronic manufacturing thing, what is it about, why are we talking these phrases here? And I think Keith also mentioned it. It's because, going forward, a lot of these systems have to be approached top down and, framework driven. For example, NVIDIA partly is where it is. Not a lot of people know because of its investment in CUDA, right? And how do you build such open ecosystems? And this is one attempt to talk about open ecosystems for telecom and generally the area that we operate in, that is radio access networks and wireless systems. Some of the ecosystem challenges, it's a bit harsh, but it's a fact that 3GPP is actually a digital colonizer. It is controlled centrally by a few oligarchs, right? And that's one of the detriments to innovation. While in principle it is open, it's too prescriptive, it's too agility, innovation limited, and creates monopolies, right? In fact, try getting a data sheet of a 5G modem from anybody. It's easier to get national secrets than that. So that's how, and that shows how difficult it is to access information. So this whole idea of holding back information is not going to get us anywhere further. Going forward for AI, fundamentally more than the model, it's the data that's important, right? If we have data, if we have open stuff along which we actually can go build more complex stuff and also, or create or promote creative destruction. One of the other challenges in telecom is basically there's very little sharing today in the telecom world. Operators share only passive electronics, which is basically the towers and fiber optics and so on. So going forward to create a better business model, you need active sharing of electronics and the spectrum itself. Practically, I mean, for spectrum is actually an oxygen for the digital economy. I mean, without easy access to spectrum, it becomes very difficult to actually build all the rest of the cool things on healthcare, on automotive and all of that. Because communication and telecom is going to be the next potential DPI. So what are the some of the trends that are there in the industry, right? I mean, at least from a telecom and a communication perspective. It's a union of three disparate stuff from some subtle perspectives, but they're all the same, of telecom, cloud, and AI, right? A lot of cloud concepts and even computer science, if you really look at it, have 2 or 3 basic concepts that have driven computer science, right? One is late binding. I mean, for those of you who know cricket, late binding is like, is trying to bat on an English cloudy morning English wicket, right? You are always told play with soft hands and also play as late as possible. Computer science, the goal of computer science is that. So from libraries to microservices to containers is to play as late as possible and to be able to bind as late as possible. And that has resulted in, all these cool technologies that Netflix offers you through microservices and stuff like that. The other trend in computer science has always been higher abstraction. We have a corollary to Moore's law. We call it the Sankhya law of abstraction, which is, every 7-8 years, I don't know the exact time frames, or maybe around a decade, your level of abstraction goes up by 2x or 3x. It's an empirical law. Again, I don't have any data to prove it, but that's what we feel. The whole of the cloud computing, all your Android stuff, all the compute that has happened today has this one particular trend. So you've gone from when we started our careers in programming in assembly to what are called today domain-specific languages. All those cool stuff that back-end and front-end that kids talk about. That's the very important aspect of, this allows you to actually double or triple your productivity. And then finally, the other one that's there in the cloud is treating something as a resource. When you treat something as a resource, you can provide that as a service. So if you treat compute as a resource, you can provide compute as a service. This allows you to monitor and also scale stuff, right? So more and more, all these concepts have to go down from software into hardware, right? And into hardware and into silicon architectures. And once we start designing that, this whole concept of trying to treat something as a resource is actually late binding in hardware. And the other important trend that's happening, I think we all know about generative AI, is the implementation agility. I call it the implementation agility, where we had static architecture, static regulatory systems. Right? Going forward, you would more and more, I think Hitesh or somebody put up that slide, more and more systems would sense, detect, and then adapt. Right? This is the OODA loop. And I believe future networks would be actually networks which actually design themselves by sensing the RF environment. Because an RF environment changes in space and in time in probably every 30 milliseconds. So what a standard developed in Europe for a US city might not hold for, optimally hold for a village in India or a village in Africa. And the final one is actually open source white box hardware and software, and I think multiple companies in multiple domains are attempting this. In our own domain, there's this trend called the Open RAN or the ORAN that's actually doing this. So what is the solution to this? I call it the India Telecom stack. I mean, there are distinctly, three models of development, or in some sense, there's the American model, then there's the Chinese model, which is the American model on the steroids, and then there's the Indian model right now. And we have shown it with the UPI, which is the Vasudhaiva Kutumbakam, right? We take everybody along with us, right? We build frameworks and allow everybody to compete. We are all frenemies. And these parallels have happened in other domains as well, right? At the beginning of my career, I remember getting hold of a C compiler or a Pascal compiler. We used to still program in Pascal those days. Was very difficult. GNU came and played people don't even know that, you have to pay, there's something called a compiler now, and you have to pay for it. Same was true in the 90s for operating systems, right? Unix operating systems. You have to shell out a lot of money. Linux changed that. And in our own recent past, we have done it through India Stack for UPI, through UPI, right? What we have done is we have broken the monopoly of 2 or 3 credit card companies and actually unleashed a new power where, the ecosystem thrives. Everybody thrives in this. So that's the idea, is to unleash an extreme openness. And then the scaling is a byproduct of that, right? And also, some of the other ones are a bit more, very technical, but I'll skip them. But today, what happens is in our networks, we are actually virtualizing implementation, not virtualizing interfaces, which means that we define static protocols. Like I said, you need to have systems that actually sense the environment and adapt to that environment. So that's not possible in today's, static systems. Some of the features are, that, each component from an optical to the different layers in the OSI stack have a bunch of standardized APIs like UPI does for manageability, telemetry, security, which is becoming a very important aspect. So some of the other features are basically every layer is provided as a platform, right? One of the reasons why today we have so much cloud computing is also because of the concept of an hypervisor that developed over the past 20 years. There are a lot of plumbing parts that should be open sourced. For example, if I'm building a 5G chip or somebody else is building a 5G chip, 70 or 80% of the work is grunt work. We all do the same things. And we waste a lot of collective money in trying to build that. And that's where half the trillion, like Keith said, hundreds of billions of dollars get wasted because of that. So we have to be able to better monetize some of those resources and also pool resources. And at the same time, concentrate on building the 20-30% differentiation that we can bring to the table. So that actually helps this. And then, every implementation component, in fact, we are looking at building silicon architectures in a virtualized way, which allows you to virtualize silicon, which means I am able to, like I said, bind resources in a silicon or in a hardware very late through a software framework. And that allows you to get most juice of the silicon architecture that's available. So one other aspect is every implementation component is auditable, which is always a problem today, right? We have a trust from a trusted source and stuff like that. The ability to have observability, which is basically important for sensing, is to pull out telemetry data and use ML techniques to do it. And then, make sure that every software and component that is there is portable across systems, so that there's not one single monopoly. No one single vendor can come and say, okay, here's my monopoly, tomorrow morning I'm going to charge you double the price of what I'm charging today. I'll skip this part. And yeah, a potential collaboration method along on the lines of the India Stack approach is that Future Labs becomes some kind of a lightly regulated NPCI, right, which actually manages the marketplace. So you go to a marketplace model, host Spectrum and other resource sharing frameworks. The industry becomes, iSpirit. iSpirit was the company, I think the consortium that actually built the first, APIs and the first zero-hour version of the India Stack. Something similar could be done. And then the academia, the third leg, can contribute expertise and build stuff around this. I believe this would unleash a level of innovation in telecom that would be pretty unprecedented, and that would be our contribution from the tech perspective for the Vasudhaiva Kutumbakam. And as an example, because we are silicon guys, we today most of our algorithms, actually, the real innovation in some of these comes from algorithms that are built by small researchers. But to build a chip for 5G for a small researcher is almost next to impossible. The ability to actually build a white-sourced silicon architecture that allows you microservice, the ability to pull in and pull out algorithms at will, to have telemetry hooks, to have virtualization hooks and then driven by a standard hypervisor will actually help us build these open architectures. And so something similar can be done for the rest of the telecom. By the way, the same approach can also be done for, while I have the UPI and the India Telecom Stack hammer in my hand, I can also visualize a India manufacturing stack where we have, we work with partners like Keynes and others who can actually come up with a standard portable thing where we can go across manufacturers, getting the same amount of quality and same kind of look and feel for the product. Thank you.